In this video, I'm going to share what I think is the most efficient way to learn about deep learning, from being a total beginner to learning about more advanced topics. To start off this video, I want to talk about mentality. Because I think even the title of this video is misleading. You will never have learned deep learning. It's always an ongoing process. You're always going to feel like a beginner, and there will always be more and more things to learn. You will never feel done. And I think any other mentality than this is going to limit you in the future. So I thought we could spend a little bit more time on this idea of developing a mentality for learning. Andrew has talked about this quite a lot, so I thought we could just give it a listen and see if we can extract some good ideas from it.
I think getting the habit of learning is key, and that means regularity. For myself, I've picked up a habit of spending some time every Saturday and every Sunday reading or studying. And so, yeah, and I think it's often not about the bursts of sustained efforts and the all-nighters, because you can only do that a limited number of times. It's the sustained effort over a long time. I think, reading 2 research papers is a nice thing to do, but the power is not reading 2 research papers, it's reading 2 research papers a week.
So I think this is really good advice, because I think we oftentimes get stuck on the idea that we're just going to do a course, or we're just going to, I don't know, take three years of our life to college or something like that, and then we're done. But embracing this idea of lifelong learning, and actually that we're never complete. And I actually feel this is a much more of an fulfilling idea. But anyways, this was a bit of a tangent. So let's go back to talking about how we would actually go about to learn this stuff. So let's talk about the prerequisites, and let's start with math. And if you haven't studied any math, that's okay, you can still get started, and I'm going to share more about that in just a moment. Now, there are 4 areas that I think are most important to machine learning in regards to math. And those are, in my opinion, in this order: linear algebra, calculus, statistics, and optimization. And just for fun, I actually found a Quora post by Andrew Ng. And the question was, I do not have strong mathematics background. What should I learn in mathematics to be able to master machine learning and AI? And he answered, I think the most important areas of math for machine learning are, in decreasing order, linear algebra, and then he said probability and statistics, and 3 calculus and 4 optimization. I swapped those 2 around. I said calculus as 2. But yeah, I'm wrong, and he's right. So let's just say you haven't studied any of these areas. Then I absolutely do not recommend that you take 6 months just to study the math. What I would say is take 1 math course, which is linear algebra. Because look, if you don't know what multiplying 2 matrices are, or taking dot products, or taking matrix inverses, everything in machine learning is going to feel like a giant black box. So there are a couple of different resources that I would use to learn about linear algebra. One is Khan Academy. I think this is a pretty good resource, and it covers the basics that you need. You could also check out this Linear Algebra OpenCourseWare, and I think this is pretty good. You have the video lectures, and he's a really good teacher as well. And then there's also, all of the assignments and all of that stuff. I also think this book by David Ley, Linear Algebra and Its Applications, is a really great book. And I just saw that it's very expensive actually on Amazon. But yeah, I think if you look around, then you can probably find it for free. I don't know. All right, so now that you've learned the basics of linear algebra, the next step is to learn the basics of programming. And the only programming language that you should learn is Python. So there are really endless of resources to learn Python programming. So I'm not going to recommend several different. I'm just going to recommend one. But note that there might be other people that disagree with the suggestion. So the course that I recommend is Introduction to Computer Science and Programming Using Python. It's a free course on EDX, and it's from MIT. And I really think this is a great course, and I recommend it. All right, so now you've come a far way. You got the basics of linear algebra, you got the basics of programming. Now you're ready to start learning directly about machine learning. Because here's the deal. To learn about machine learning, you have to do machine learning. So the title of this video is How to Learn Deep Learning, and we will get into the specifics of deep learning in a second. But as I'm sure you're familiar with, deep learning is a subset of machine learning. And I think learning the fundamentals of machine learning first is going to serve you well. So the first course that I recommend, that I started with, and I've seen a lot of other people start with, and that has pretty much legendary status at this point, is Machine Learning by Andrew Ng. As I said, the machine learning course has legendary status. It's one of the best courses in my opinion. And they actually spoke about this on a podcast. So let's listen to it.
Course that I taught through Stanford remains one of the most popular courses on Coursera.
To this day, it's probably one of the courses, sort of, if I ask somebody, how did you get into machine learning, or how did you fall in love with machine learning, or would get you interested, it always goes back to Andrew Ng at some point. So you've influenced, the amount of people you've influenced is ridiculous. So for that, I'm sure I speak for a lot of people to say big thank you.
Yeah, you do, Lex. You speak for all of us. So Andrew Ng's courses are really, I would say, the best for learning about deep learning and machine learning. And I was thinking that we could take a deeper look at that specific course. So the course more specifically is Machine Learning by Stanford University, where Andrew Ng is the teacher. So let's see if I remember. For week one, basically it was just talking about the the basics of machine learning. What is machine learning? How do we define it? It really builds it from the foundation, assuming you don't know anything about machine learning. And then it goes some basic algorithms, linear regression, and he even does a linear algebra review. And then he does linear regression for multiple variables. And then, so this is sort of a con of this course. It's still a great course, and I recommend it, is that you're going to use Octave instead of Python. But really, it's not really that big of a deal. If you know Python, it's going to be super easy to learn Octave. It's just going to be about Googling some specific syntax for what it is you want to do. So this is really a limitation. Sort of the focus is on the concepts rather than on the programming. And then on the week 3, there's a logistic regression, regularization, and then it even goes and talks about neural networks, which you would learn a lot more in a course I'm going to talk about soon. But he sort of talks about the basics. And if I remember correctly, this is a bit outdated, I would say, but it's still relevant. And the basics of neural networks haven't changed for a long time. And then sort of some advice for applying machine learning, system design of machine learning, support vector machines, unsupervised learning. I think that it talks about the k-means algorithm and so on. If you're familiar, if you don't know any of this, then that's fine. Anomaly detection, recommender system. Really, he builds up a solid foundation in machine learning, and he builds it up from assuming no previous knowledge. And that's also why I think this course is so popular. Now, this course is free. You can do the entire course for free. But if you want to have a certificate that you did the course and you can put it on LinkedIn and stuff like that, then you can purchase it for, I'm not really sure how much, but I'm going to have an affiliate link in the description if you do decide to buy the certificate for the course. All right, so look, now you know linear algebra, you know the basics of programming, and you also have a foundation in machine learning. The next step now is to learn about deep learning. So the course, or rather specialization, that I recommend for deep learning is the Deep Learning Specialization, also by Andrew Ng. So it has 242,000 ratings. It's rated 4.8 out of 5. So this is a really, really, really good course. And I can confirm. So the only problem, or what I think is the con, is that it costs about $50 a month, and it's it's approximately 4 months to complete. Although I completed it in 1 month, and because the suggested is 5 hours a week. So I mean, if you're spending an actual serious amount of time, like 8 hours a day, studying this specialization, it's going to take about a month. At least that's what it took for me. He talked about this in in the podcast as well is that if you can't afford it, there's financial aid that's available for those that simply can't afford it. So you could try and apply for that. But yeah, if you can afford it, this is the best, in my opinion, the best for building a foundation in deep learning. And so the courses, you start with learning about neural networks and deep learning. And in the end of this course, I believe you actually build a neural network from scratch, sort of in NumPy or something like that. And then you learn about hyperparameter and regularization and optimization techniques, sort of how to make neural networks converge faster. There's been a lot of progress in optimization in just a few years, and that's really made a big difference in training neural nets. And then he has a course specifically, so I didn't say it, the specialization is 5 courses in total. And the third course is a sort of structuring machine learning project, so that it's a more like a practical knowledge of how do you go about finding data, and when do you know when to collect more data, when should you not collect more data, and so on. So more practical know-how. And then convolutional neural networks for image classification. And then course 5 is more natural language processing, and it goes into sequence-to-sequence networks and sort of briefly mentions attention models and so on. Yeah, and you also go to speech recognition. There's a lot of stuff that you learn from this specialization, and if you can't afford it, there are at least also on YouTube are all the video lectures. But if you are enrolled in the course, you also have access to the programming assignments and all of that. So this is a really, really good course. I recommend it. And also, I'm gonna have if you do decide to enroll in this specialization, I'm gonna have an affiliate link in the description. So now you have a really strong foundation to build on. And in my view, you have 3 things that you can do now. The first is you can start by doing more advanced courses. And the second is you can start replicating research papers. And the third is by doing your own projects. So I feel all of these are good options. And let's just start with the first one. If you want to do more advanced courses, which should you do at this point? Now, I know what you might be thinking, all right? What, am I just going to do courses for the rest of my life? When am I going to actually start doing stuff? Well, let's listen to the man himself.
Early parts of a career coursework, like the deep learning specialization, is a very efficient way to master this material. In fact, one thing I see at Stanford, some of my PhD students want to jump into research right away. And I actually tend to say, look, in your first couple of years as a PhD student, spend time taking courses because it lays a foundation. It's fine if you're less productive in your first couple of years. You'll be better off in the long term.
And I've kind of heard this before, that people sort of think that people just do courses and they actually don't create anything. But so it's not that you're going to do courses for the rest of your life. Just that in the beginning phase, it's very efficient to do courses. And as he says himself, his PhD students end up being more productive if they actually spend the first amount of time to just continue learning by doing more advanced courses. So the first course that I think is really good is CS231N, and you have all the video lectures on YouTube. And this kind of goes in depth into convolutional neural networks, and I would say is sort of an extension of the deep learning specialization, specifically the course 4 of the deep learning specialization. And it goes into more depth, I would say. So in sort of there's some material that is in the specialization as well, but then I would say that they go beyond that, and it's still a very good course to do. And so you have the video lectures, and then you have sort of the assignments. And so what you do here is you can see image classification, k-nearest neighbor, and then fully connected, batch norm, dropout. You even go into some frameworks now, so TensorFlow, PyTorch, and then image captioning, neural net visualization, style transfer, and then GANs. All right, so the CS231 is more for images. And then you have CS224, which is natural language processing. So this is also a great course, and I would say this is a more in-depth course than this last course of the specialization. So the specialization more introduces these concepts, and here you really go into depth. And then also, let's see. All right, and then for the CS224 assignments, you also have them right here on the course website. And you sort of have course material. So you have the lectures, but you also have the suggested readings, the sort of the I don't know, the PowerPoints, and then the lecture notes, and then the assignment one. You can sort of read about the these are in Jupyter Notebooks. You have all of them on this site. So those are two courses that I think are great. And then there are some other ones that I actually haven't done. So I can't say if they are that good or not. But the ones that people talk about a lot is Fast AI. And so I think this is in two parts. And yeah, so just Fast AI talks a little bit, or the mindset of Fast AI is that they want you to be able to build state-of-the-art models as quick as possible. And it's okay if you don't really understand what's going on in the beginning, because in that way, I guess you sort of keep being motivated because you can do all of this cool stuff. And I would say Andrew Ng is sort of on an opposite approach in that he wants you to build it up from the foundation. Yeah, I'm gonna do the Fast AI course at some point, so I'm gonna have more thoughts on it. I just know that this is one thing that people oftentimes write about. And then you have the Udacity Nanodegree. I know people talk a lot about this as well. I haven't done it, so I don't know if it's a good. And then you also have the Natural Language NLP Specialization. Again, I'm not sure of this course. I'm not sure what they do. I haven't done it, and there's quite few ratings, and it's quite low. I know this is pretty new, so I'm gonna do it at some point, and I might do a review on it at that point. But just showing you sort of what you have available, and what I recommend, what I did, and then you can sort of read a little bit more if you want about the specific courses. And if there's anything I've missed, you can write a comment and share your experience with other courses. All right, so continuing to take more advanced courses is definitely one way, and it's a very efficient way to learn, in my opinion. But as I said, you have more options, so let's go to the point number 2, which is replicating research papers. So replicating research papers is something that I've done a lot, and we can just go to my channel, and we can go to playlists. And if we go to sort of the PyTorch tutorials I've done, and we go to, let's say the convolutional neural network architectures like the VGG network, GoogleNet, ResNet, even neural style transfer, GANs, all of these come from research papers. So if we just look at, I don't know, this video I've done, from the beginning, I sort of I go through the paper, we read the paper, and then we go through what did they actually, what did they do in the implementation, and then we try to code it, right? That's what I've done a lot from pretty much. So a lot of my videos are just reading papers and then replicating them and then try to explain them in a way that's easy to understand. So this is one way that I've personally learned a lot from, and I think is a very efficient way to learn. And it's quite simple in that you take an interesting research paper, you read it, and then you try to replicate what they did in that paper. Now, you also have a third option, which I believe will arise naturally because you will just have ideas of things you find interesting. Either when you're doing courses or you're replicating some research paper, you're going to start to have your own ideas. Now, that could be to build an app of something you find interesting, build a website, or just an interesting task that you want to explore. So I wouldn't worry too much about project ideas. They really will just arise naturally. I think doing projects is a very, very efficient way to learn as well. I do want to caution, however, on taking too large projects too early. You really want to build up the difficulty of the project you're taking on. So you want to start with something that you pretty much know you can do. And then you want to take another that you pretty much know you can do just slightly above your current level. From my experience, I feel that sometimes I'm taking on projects that are just too difficult, and you pretty much get stuck and you lose motivation. So you don't want that. You want to always have a challenge that you feel you can do, but it's just slightly above your current level. And for that, I recommend rather starting too easy rather than too difficult. I also feel I want to mention something about books. And I think deep learning is an area that is developing so quickly that the books really are outdated. And the best way is really to read research papers. But with that said, I think learning the fundamental concepts, books can be very helpful for that. And so what I recommend is using books more as a reference rather than following from start to end. And the book I would recommend is the Deep Learning book by Ian Goodfellow. So those are some of my thoughts on how to get started, and hopefully you found this video useful. Let me know if you have any questions in the comment section below. I pretty much answer all of the questions, and so with that said, I just want to wish you the best of luck in your journey in machine learning. Hej då!